Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're back to working on this little Monarch 10EE lathe that I introduced to you guys a couple of weeks ago in a video that had some issues with the electrical system in it. We'll just leave it at that. What's in here now isn't really working right. And I really want to update the electronics in this thing where it's going to do what it's supposed to do. So for those that don't know much about these Monarch 10EEs, over the years they came with several different drive systems in here. These lathes, particularly the early ones, really, when I say early, probably 1970s on back, they all had DC motors in them, direct current motors in them. Direct current motors really do a great job in certain applications, and in a lathe like this, a DC motor is really the ideal type of motor to be in one. You can do variable speed relatively easily. You got torque throughout the whole range. There's a lot of advantages to having a DC motor. This has the original DC motor in it, but what it didn't have when I got it was the original drive system or the electronics that drove it. Now I've got two 10EEs, and one of them I'm kind of restoring. It's a long-term project, but it's an earlier version of this. It also has a DC motor in it. The earlier lathe had what's called a motor generator set in it. It had a three-phase motor that powered a DC generator, and then that DC generator powered the DC motor. And there was, again, electronics in there where you could do the variable speed and so forth like that made it all work. When I got that lathe, the whole motor generator set, it was shot. It had quit working and it was a mess. I pulled it all out. And as we restore that machine, we're going to update it again with a modern electrical system. This lathe here was a 1950s version. My first one was a 1940s World War II era. This one's from the early 1950s, and it kind of had a later generation of the electronics in here. There was basically a drawer back here on the back side that you pulled out, and in it originally was a bank of transformers. It had some electrical tubes in it. You remember the old tubes like used to be in radios and TVs way back a long time ago? Yeah, it had all that in there. They called this model the works in a drawer. So basically all the electronics were in there. When I got this lathe, that was all gone. It had been stripped out. And someone had jury-rigged up a system in here with a variac, a transformer, and some other components in here, and supposedly it was working at some point, although we were unable to really get it to work properly. I've decided we're going to take all this out, and we're going to go with a more modern DC drive setup. Now, I've done a good bit of research before I ever got into this, and over on the Practical Machinists forum, there's quite a few threads of people that have retrofitted these Monarchs, and there's some guys out there that have done a really good job of coming up with a pretty good package of electronics that you can put in these. The problem is that over the years, they had different components inside there, different motors, different setups, and depending on the vintage of your lathe, kind of depends on whether the electrical drawings and stuff that I was able to find would work, and really what was out there was for a little bit newer model lathe than the two that I'm trying to do. So I was kind of banging my head against the wall, kind of wondering what to do. Fortunately, one of my awesome viewers out there, John, he reached out to me. He's a retired electrical engineer. He said, hey, I'd like to help you with your lathe. And boy, has he helped. He has really kind of taken the work that was done over on the Practical Machinist site, and through some back and forth and some testing and whatever, he has designed an electronic system to work in this thing using a couple of different off-the-shelf DC drives, plus some other components to kind of make everything work. In the process, we're stripping everything out of here, and we're basically starting from scratch, starting from a blank piece of paper and going to do this thing right. This particular motor is a little bit complicated. Some people say, well, just go buy an off-the-shelf DC drive to go in there. They make DC drives that are designed to drive DC motors. And yes, that is an option. The problem is that the DC drives that are out there really aren't designed to drive this particular motor. This one has a higher voltage than what most of the DC drives will properly handle, and also this motor is a 4-wire system where you're not just changing the armature voltage. I guess it's the voltage going to the armature. You're not only changing that for the direct current variable speed, but you also have to change the field in the motor. So we actually, in essence, kind of have 2 different DC drives that are required to make this thing, 2 different DC drives that are kind of made to make this thing work. And right now, honestly, most of it's way over my head. I'm going to be working myself through it with a lot of John's help. But today's project is we're going to be gutting this machine out, getting everything out of here, and kind of getting ready to put the new system in. I've got the stuff over here, the electronics. It's all got to be wired up. I've got a wiring diagram to do everything. I got to make some fabricate a little bracket to hold all my electrical components. But before we can do that, we need to get all this stuff out to make room for the new. So, long introduction. Let's get at it and get her done. So here's the deal, guys. We're going to strip all this stuff out. I'm just going to come in here and just start disassembling. There's a aluminum plate here that has a rectifier and some wiring on it. I think before I do anything else, I'm replacing all the wiring in this. And actually, we are going to keep a couple of the original components on this machine, but there's really no reason for me to even worry about where these wires trace to, because nothing is going back like it was originally. So I'm just going to come in here and cut some of these wires. Even if we're keeping the component, it's all getting rewired, new wiring, just because I want to make sure everything's good. See, I'm going to need a wrench to hold that nut on the bottom there. All right, that's out of there. Now, guys, we're replacing all the electronics. I am going to try to keep the original controls on here. So we'll still have use the forward and reverse switch. We're going to tap into the potentiometer, or put a new potentiometer, but in there that's going to be our speed control. We're going to keep the main on-off switch down here. So from the outside, everything's going to be using the original controls. We're not going to replace that. We will rewire all of it. But I do need to get all this stuff out of here. So let's get this big variac out. That should loosen that up. That thing's heavy. Yeah. Trim these wires up on it. This variac is a rather expensive item if you need to buy one. I'm going to probably hang on to it in case I ever need it for another project. It'll be nice to have. It's actually a pretty nice unit. All right, just to simplify things, we're going to just get some of these wires out of here. Now there's a big transformer back here in the back, and I need to get it out of here as well. Let's see what I need to do to get that out of there. Got a swivel head on an extension. See if I can reach in there and grab that. That worked. All right, there's another one over here. Can't quite get in there on that one. We'll have to resort to the wrench here, it looks like. All right, I got that one out. Now imagine there's 2 more bolts on the other end of this transformer. We're going to come in this little side door over here and try to get those out. So we have an access panel right here on the front, a couple of cam locks. in there, and that door comes right out, and I can see my nut and bolt. Find my socket, put that back on here. And that one's out. I can get the other one from the other side. There's another access door on the back, and we'll go over there and grab that one and take it out, and we should be able to pull that transformer out. And that should come right on out. And that is one heavy transformer. There we go. We'll get my hand trucks and get this out of the way. All right, we got the board, or the drawer, all cleaned out and got a full area. This is where I'm going to basically build my new system into. And what I've got is I've just got a piece of aluminum panel here. This is a 1/4 inch thick piece of aluminum, and we're going to be mounting components to this. And this is going to basically be mounted in this drawer, straight up and down. It'll slide in and out, just like the original did. And we will have different components and stuff mounted on it for us to be able to work with. So I'm going to have to fabricate some kind of bracket to kind of hold this up and put it in there. We will actually build the electronics and troubleshoot everything over on the bench. But the plan is that once we get everything working right, I can just come drop it down in here, bolt it down to the drawer, and we'll be ready to roll. That's the game plan. I believe that big transformer in there may have been original to the lathe. I know there's a bunch of transformers in the original works in the drawer, and it looks like it's been there the whole time. The paint under it's perfect. I know you can't see it, and it just looks like it probably was original. And we're going to need a transformer, boost transformer later on for part of this. Who knows? We may end up reusing that. We'll have to play that by ear when we get there and see what we need and see if that transformer will work. Regardless, I'm sure that transformer, that's a nice big transformer. It'll get used for something somewhere along the line. It'll get repurposed. Basically, there's just 4 wires coming into the back of this. There's a piece of flexible conduit type stuff that moves out with a drawer, and it goes up. I believe those 4 wires are the 4 wires that go to the motor to run everything. I think, maybe not. We'll have to figure all that out too. But like I said, we're going to put all new wires in here anyway. So making progress. Let's go around the other side. We got some stuff we need to tear out over there as well. I'm back over here on the headstock end of the lathe, and this is where the motor is. And inside of here, there was this box. This is original to the lathe, and it's actually all going to be going. We're not going to be utilizing any of this, but this was some of the original components that were in here. And basically what's inside this box is forward reverse contactors. So basically you got a contactor over here, there's a thing in the middle where it'll only allow one side or the other to be in, and whenever you pushed or whenever you moved the lever for forward, it would engage one of these contacts, boom, it'd shut it, and it would turn the motor in one direction. When you moved the lever to the neutral, it would pop out, and whenever you went to reverse, it would push the other contactor in. It's just like a modern motor starter, but this one was designed for working with DC, obviously. One cool thing about it is on the back side of this, you see these coils here? These are just a big resistor, and what would happen is whenever you stopped the motor, if you put it into neutral, the power would not be going to the motor anymore, but it would still be spinning from the centrifugal force or whatever, the weight or whatever in there until it wound down. Well, when you do that, you're basically turning that motor into a generator. It's creating electricity, and it would channel that electricity into these resistors, and they would heat up. That would just use that electricity up, and that worked as a motor brake. So that's what basically stopped the motor from spinning. So in our new setup, none of this is going to be used. We're basically, a lot of the functionality that this box does is built into the controllers we're going to be putting on there. That we are going to have some contactors, but we're going to be using more modern solid state contactors. I will tell you that with these, I was playing around with it when I had it running. I took the cover off, and man, you talk about a flash arc. Every time these things would engage and disengage, you just see a spark come across them. And that was pretty common with this particular style of contactor. But all of that's coming out. We're not going to utilize any of it. We're going to be replacing it all. There's a bunch of wires going to it. And, you know, I almost hate to do it, but we're just going to snip them all off because we're not using any of it. There we go, the one doing it now. We'll set that over in the scrap pile. This was mounted in here on some hinges. There was a little nut down on the bottom. When you unscrewed it, it would roll out. It was really mounted in here neat. I had already taken that out because I had to get back to the motor and it was in the way. So off that goes. I'm back here on the back of the lathe now, and this is where the power comes in. There's a disconnect here. We're actually going to keep this. We're going to have to replace it. There's nothing wrong with this one. We do need a main disconnect to be able to just turn the power on and off to the machine. There's also a control transformer back here. This is the control transformer that takes the voltage that's coming in and takes it down to 110 volts or whatever voltage was used in here. I'm assuming it's 110. But I think we're probably going to keep this. I've actually got another control transformer I can put on here. This one did get a little bit hot when we were testing it out, and we had the wrong voltage hooked up to it originally because we were unclear of what voltage it needed to run on. And it did smoke a little bit, but I don't think there was any damage done to it. I checked it all out, and it looks good. So I'm going to probably do a little bit more checking. If I need to, I got another one. We can just swap them out. But if this one still works, we're just going to probably leave it. This contactor up here, whenever you hit the main on-off button over there, it would engage this contactor. And what this is basically doing, all it did was just give power to the whole system. So this is kind of the master on and off. When you turn this on, you're just turning the power onto the machine. And then whenever you move the switch up front, forward and reverse, that's what would engage the motor and all that kind of stuff. This is coming out. We could have reused it. There's really nothing wrong with it, but just to keep our whole new system as simple as possible, it was going to be easier just to put a contactor over there on the panel we're going to build and do that. So I'm going to pull this out. These wires here go to the switch up front for the forward and reverse. I'm going to probably try to leave these wires as long as I can until I'll probably end up replacing all that, but I want to keep that in there. And yeah, we'll just go ahead and take all this other stuff out of here. And like I said, we're going to be starting from scratch, and it needs to go anyway. So there we go. Let me get that done and get that stripped off of here. Grab these. So again, I'm not going to worry about unhooking all these. We're just going to cut the wires. Everything's being replaced. And we're going to start from scratch with all of our wiring. So go ahead and just cut all this out. Now there's nothing wrong with this contactor. It will probably also get recycled and used somewhere. I'm always looking for motor starters and so forth when I'm rebuilding machines, and often get stuff that's got junk in it and need to replace it. This is in good shape, so like I said, don't be surprised if someone sees it again down the road. I missed one wire. Here we go. Nice Cutler hammer. Motor starter. I'm also going to go ahead and just take this little terminal block out of here. It's interesting, they have resistors on a bunch of those. Mighty close together. I don't think this is original to the machine, though. I think this was added in when they did their conversion. This terminal block. There we go. Get that out of there. And you can tell a lot of these wires, those wires are probably original to the lathe, but just about everything else in here, pretty sure was done when they did the rewire a while back. All right, let's see if we can get those wires pulled out. I got my headlight on so I can see what I'm doing better, and right now I'm pulling the wires out of this transformer, and they are being real stubborn, so I think I've already kind of cut them on the inside. We got this little piece of flexible conduit here that these are going through. I think I'm going to loosen that up on both ends. We got some 90s in here, and the wires just aren't wanting to pull around them real easily. There we go. Got that out. And we'll just kind of loosely put that back in there. There's no reason to not reuse that. I will say that this is all new wiring. Their box in here is new. It was added whenever they added this stuff. I believe these wires will pull out now. Those were going down to the transformer. And see, there were some, I think all these wires will pull out of there too. All right, a little bit more out. I've also already pulled a bunch of my wires and stuff out. And I will comment that I said a while ago 4 wires going to this motor. This motor actually has 6 wires going to it, and I can't remember what the other 2 wires do. My other motor is a 4-wire motor. This one's a 6-wire motor. We can basically use the same electronics in both the old lathe and the new lathe. At least we think we can. There are going to be a couple little small differences, but in the grand scheme of things, it's going to be very, very similar. All right. I think that these 3 wires are going to go up to the front to the on-off switch, and I'm not sure where these are going to. Those may go to the front on-off switch also. Let's see. Okay, so I'm wrong. These 3 wires, this is the main power. It's coming to the disconnect. One. 2 and 3. And then there's 3 wires here. These go to the, or 4, 3 wires going to the on-off button up front. And we'll get those, we'll probably pull those out from the front side. All right, we've about got this thing stripped down. Those went to the potentiometer. All right. Let's get these wires pulled through, and I think we'll have all the wires out of here. So this is the main power on and off. You would just turn it on and off right there. So we're going to pull that out, and those 3 wires to the back should be wired into this. This is just like any other 3-wire motor starter switch. You push the on button, it jumps the circuit, energizes the coil in the motor starter, and then you release the button. The voltage is going through the coil, so you don't need the button pushed in anymore. And then when you push the stop button, it breaks that circuit, collapses that circuit, and the coil drops out, and you're off. So I think what I'm going to do is just put these screws right back in here where I don't lose them. It was missing one. We probably got one in the cabinet we can replace it with. Motor generator start stop. That's an older tag. This didn't have a motor generator, but it was still a start and stop button. All right, I think we're got all our wires pulled out. And there is the rat's nest of all the wires that were in that lathe that we pulled out. And like I said, I'm just going to start from scratch. You know, honestly, the wiring was not in bad shape. We could have reused a lot of it, but it would have taken forever to track everything down, figure out what wire went where, having to check it with the meter, mark everything. It's just going to be a lot easier to just wire this thing from scratch. And that's exactly what we're going to do and what we're going to be starting on very soon. And just a quick look inside the back of the lathe here. The only wires there are the 6 wires coming out of the motor. I'm going to leave them there for now. I will actually replace those wires when I do my final wiring, but I'm going to leave them like that and just tap into those when I'm doing my testing over on the bench. We're going to need longer wires, but whenever we do, we'll pull those little pieces out and tie it into the motor. You can see where I pulled the pecker head off back there, and you can see the wires kind of sticking out. Those are marked in there as to what each wire is. We'll probably have to ohm those out to figure out which wire is which on the other end, but no big deal. We can do that one pretty easily. So there you go. That's the big DC motor that will be powering this thing. Well, there we go. I feel better having all this done. We've got a clean slate to start with. Up next is we're going to be fabricating that aluminum panel that's going to fit down in the drawer down below, and we will then get all of our electronic components. I've got those here behind it. I'm going to feature all that in an upcoming video. We'll get all that stuff mounted on there, start wiring this thing up. Like I mentioned a minute ago, my game plan is I'm going to basically be working off the bench. We'll have some leads going over to the wire. We've got some troubleshooting that needs to be done, some testing that needs to be done. I'm not going to go into a lot of it right now, but there's some pretty cool things that we're wanting to do from a control standpoint on this. And there's a lot of testing that we have to do in order to figure out exactly how we need to configure some of that stuff. And we're going to be doing that on the bench rather than trying to crawl down here on the floor and do that. Once we get the electronics completely finalized, we'll mount it in the lathe and we'll be ready to go. And like I said, my plan is that we will be using all the original controls on the lathe. So you got the on-off switch for the power. We got our forward and reverse drum switch in here. That we're going to be using that. And then there's a potentiometer down here on this dial that when you turn it, that is what changes the variable speed on the lathe. We're going to be using all the original outward controls, but of course all brand new modern electronics on the inside to hopefully get everything working like it should. And with any luck, we're going to have us a nice little 10EE lathe that we can use in the shop. And this will be, I guess you call the prototype for the system that we're going to put in my second 10EE, the one that I'm rebuilding. This one, I just want to get running. We're going to use it as it is. This should be an operating lathe other than the drive system. So, but we've got to do all this for the other lathe that I'm totally rebuilding and rescraping in the whole 9 yards. It's going to basically be a brand new lathe when I get through with it. We're still a ways from really getting into that project. But like I said, this will kind of be the prototype to get all the kinks worked out to get that one going down the road. We got that, guys. That's going to be a wrap. As always, thank you so much for watching. Please do subscribe to my channel if you haven't already. Thumbs up, comments, greatly appreciate it. Really helps out with the analytics on YouTube. And if you haven't already, subscribe to the channel. Hit that bell icon up there to get notifications when new videos are posted. And with that, guys, we will catch you on the next video. Again, thanks for watching.